NASA's Voyager 1 detects the eerie hum from interstellar space more than 13.2 billion miles from Earth. 44 years ago, on September 5, 1977, NASA launched Voyager 1 to explore the outer planets of our solar system. They were launched in 1977 to take advantage of a favorable alignment of Jupiter and Saturn to fly near them while collecting data for transmission back to Earth. Voyager 1 flew by Jupiter on March 5, 1979. It took pictures of Jupiter for 100 hours to generate a time-lapse movie of Jupiter rotation. The spacecraft also encountered several of Jupiter's moons, returning spectacular photos of their terrains and opening up completely new worlds for planetary scientists. The spacecraft also discovered 2 new moons, Thebe and Metis. Voyager 1 headed to its next target, the second largest planet in the solar system. On November 12, 1980, Voyager 1 flyby Saturn officially became the second spacecraft ever visit this ring planet. During its flyby, NASA directed the spacecraft to its most interesting target, Titan, the largest moon of Saturn. Images showed a thick atmosphere that completely hid the surface. The spacecraft found that the moon's atmosphere was composed of 90% nitrogen. Because of the specific requirements for the Titan flyby, the spacecraft could not explore Uranus and Neptune. Using Saturn gravity, it speeds up on its trajectory to escape solar system. On February 14, 1990, 4 billion miles from the Sun, Voyager 1's cameras were pointed backward and captured about 60 images of the Sun and planets, the first portrait of our solar system as seen from the outside. The probe captures our blue little tiny Earth. Became known as Pale Blue Dot, an image made famous by Cornell University professor and Voyager science team member Carl Sagan. Traveling at 38,000 miles per hour, on August of 2012, Voyager 1 became the first spacecraft exited the heliosphere and began measuring the interstellar environment. Heliosphere is a solar wind forms like a bubble. A bubble that acts as a shield that protects the planets from interstellar radiation, which extends about 11 billion miles from the Sun until past the orbits of the planets until it reaches the heliopause. The heliosphere's outermost edge, a mark that starts and a boundary of itself and the interstellar space. Even though 44 years has passed at 14 billion miles, Voyager 1 still sending signals and communicating back to Earth throughout the deep space network. Back in 2014, this outburst were detected for the first time by Voyager's plasma wave system. This shock wave, also known as the tsunami wave, throwing out a magnetic cloud of plasma from its surface. 9 years after its exit, NASA's Voyager 1 detects an eerie persistent hum generated by the constant vibration of small amounts of gas in interstellar space. According to research published in journal Nature Astronomy, from the data that was sent back from one of Voyager's instruments, the plasma wave system detects a plasma waves or interstellar gas. One of the authors, a doctoral student at Cornell University, Stella Kovalko, said, "It's very faint and monotone because it's in a narrow frequency bandwidth." This is an audio clip taken from the instrument's data. These faint plasma waves, researchers say, are different from other detections produced in the immense nothingness of outer space. For example, the Sun sometimes gets cranky and erupts, spewing radiation into space. These outbursts have a distinct signature. James Cordes, a researcher at Cornell, compares it to a lightning burst. Lightning bursts were once used to determine the density of interstellar plasma. However, the low steady hum indicates that Voyager is gathering plenty of data in the absence of solar outbursts, indicating that we don't need a fortuitous occurrence linked to the Sun to test interstellar plasma. Voyager 1's data can help scientists understand the interactions between the interstellar medium and the Sun's solar wind, a steady stream of charged particles. NASA's Voyager 1 spacecraft became the farthest human-built object from Earth. It has remained operational long past expectations and continues to send information about its journeys back to Earth. Accompanying with its odyssey in deep space are one of the 2 Voyager's golden records. The records contain sounds and images selected to portray the diversity of life and culture on Earth, and are intended for any intelligent extraterrestrial life form who may find them. The records are a sort of time capsule. According to NASA, the 2 probes have sufficient electricity and fuel to operate. Beyond that, NASA starts taking a much longer view, noting that in 40,000 years or so Voyager 1 will drift within 1.6 light-years or 9.3 trillion miles of AC plus 793888, a star in the constellation of Camelopardalis. As a result of this research, we will learn more about our universe beyond the influence of our own sun. This leads to a new mission heading in the universe, exploring the deep corners of unknown space.